I've never had any training in cell phone technology or how cell phones and cell towers work to get your location, nor have I had any training on how GPS satellites do the same thing to find your location. But I can tell you how, by just using some 3D geometry and some logic, that a normal human with just a normal human brain could look at the data from a cell phone tower or from a GPS satellite and find the location of the device that is emitting that signal, whether it be a cell phone that is communicating with a tower or a GPS device that is communicating with a satellite. Here's the clues I got off the internet, and maybe they're true, maybe not. It's the internet. Okay, so what I read was you need 3 towers if we're talking about just cell phones. You'll need 3 towers to get the location, and you'll need a 4th tower to get the altitude or the exact location, meaning you could be in hilly terrain or up in a helicopter, but the internet also said the more towers the better. Those are the hints. Pause the video if you want to figure it out for yourself, otherwise I'll show what I got. And again, what I'm showing is not cell phone technology, it's just simple 3D geometry, so that if a device is communicating back and forth with a tower as they send signals back and forth, the numbers on that tower or the data from that tower will give the exact location of a person. Okay, pause the video if you want to figure it out for yourself. Otherwise, I'll show what I got on the next page. Actually, it's not the next page, it's the same page. I just folded it. So, from what I understand and from what I've read, cell phone towers and cell phones or GPS satellites and GPS devices, they're constantly sending signals back and forth, bouncing radio waves back and forth to each other. They look at how much time it takes for a signal, a radio wave, to go from a tower to a phone, and then from the phone back to the tower. You use the simple equation of distance over time equals velocity. Therefore, velocity times time equals your distance. You take velocity as the speed of light, which is also the same as the speed of a radio wave. Multiply it by the time it takes for a signal to go back and forth. So that's your velocity times time, and that will give you your distance to the tower. I've also read that there is some computer nuances there where they take into account the amount of time it takes for the computers to process that information. So I'll just start listing off the number of towers and what they do. If you have a single tower right here in the middle, it will send out its radio waves in a sphere. So it's like that tower is at the center of a big ball. It'll send a signal back and forth to a cell phone, and it'll take so long, a certain amount of time for that signal to go back and forth. Therefore, that tower will know that that device or that cell phone is somewhere on the surface of a sphere. And the radius of that sphere is 2 kilometers, for example. That a cell phone could be in someone's pocket that is in a helicopter overhead, 2 kilometers overhead from that tower. So we use a second tower. The spheres from these 2 towers will overlap, and again we want the surface area of the sphere because that is where the cell phone will be located. You can take 2 squishy foam balls or 2 stress balls, cut a section out of each of those, and glue them together, and it'll look like this. There's some sort of asteroid that looks like that, where it's 2 asteroids that stuck together, forming this like asymmetric snowman appearance. I forgot what it's called though. But the point is, we have 2 spheres that are stuck together. You can take a felt tip pin. If you take these 2 stress balls or foam balls and cut a section off of them and glue them together, take a felt tip pin and draw a circle around where those 2 foam balls meet. That ink mark will be on the surface of both of those balls or both of those spheres. Thus, we will have a ring. And this will be a ring of possibility, because that means the cell phone or device that's emitting the signal is somewhere on that ring, because that ring is on the surface of both of those spheres. If the person happens to be located exactly on a straight line between those 2 towers, then we will have 2 spheres just barely touching at a single point. In that case, the data from one cell phone tower will say that this person is 2 kilometers away. The data from the other cell phone tower will say that this person is 1 kilometer away. And there will only be one point in the whole universe that is exactly 2 kilometers from one tower and 1 kilometer from another tower. So in that case, you wouldn't have a ring, you would just have a single point. But the farther away from that midline, I guess I should draw this. So this is a midline between the two towers. Most likely people will not be located on that midline between the two towers. So the farther away the person walks from that midline, then the larger your ring will get. So I think this is cool because just a normal person with a normal human brain could look at the numbers from each cell phone tower, even though we only have 2 cell phone towers. This cell phone tower will say that the person is 2 kilometers away. So you can get out your circle compass, not your navigating compass that's like magnetic, but like a circle compass to draw circles. By the way, I hate the fact that both of those have the same name. So pull out your circle compass and draw a 2-kilometer circle around that tower. And you're drawing it on paper, on a map, and it's 2-dimensional, so just pretend it's a sphere that's 3-dimensional. And this other tower says that the device or the person with the device is 1 kilometer away. So get out your circle drawing compass and draw a 1-kilometer circle around that tower. And voila, you will see that both of these circles overlap. If they didn't overlap, then you would know that person had to be on the line that directly connects both cell phone towers. But most likely these circles are going to overlap. Thus, you'll know this person is somewhere on the ring between those 2 towers. And again, they could be up in a helicopter flying overhead above those towers, or they could be down in a deep ravine well below those 2 towers. And notice when you look at this ring, we will have a possible or potential high elevation and a potential low elevation and any potential location in between. So 1 tower gives you the surface area of a sphere, 2 towers will give you the location that is somewhere on a ring. Use a 3rd tower, we'll have a sphere from the 3rd tower, add that to the ring from your other 2 towers, and this 3rd tower will say that that device is somewhere 4 kilometers away on the surface of its sphere, and that ring will overlap with the sphere from the 3rd tower. So now you have 2 points on that ring where the person could be. Notice here we have a high elevation and a low elevation, but we don't know which one it is. So we use a 4th tower, and the sphere on that 4th tower will either contact that ring or that point either at the high elevation or low elevation. Thus we will have a location plus an altitude. I think actually this would be a really fun game, like a scavenger hunt. You just look at the raw numbers from each tower and you simply draw out your circles with a circle drawing compass on a map. So 1 tower will say that the person is 3 kilometers away, so you draw a 3-kilometer radius circle, then do the same for a 2nd tower and a 3rd tower. And you can see where all 3 of those circles meet. That would have to be the location of the person. But then again, that's barring any errors, because I've read that there is some margin of error here, so that's why they prefer to use as many towers as possible. You could even hide some sort of treasure or something, and it'd be like a different form of geocaching. So yeah, that would be a lot of fun. And granted, these are just 2-dimensional circles and not 3-dimensional spheres, but I think they could get you pretty close to the location if you just looked at the raw numbers and drew out some circles on a map. I'm just guessing anyways. By the way, it does make sense to call this triangulation because these 3 towers literally form a triangle. YouTube AI says that term triangulation is still used colloquially, but trilateralization is more accurate because it uses more towers, like the 4th tower, for example. So I don't know about any of that stuff. AI says a lot of stuff and a lot of it's wrong. So I may just keep calling it triangulation. I'd hate to live my life based on the advice from YouTube AI.